All right, so here's another one. Now we've got the integral of 7 times e to the power of 2 sine of x times the cosine of x dx. So this one's a little bit more complicated in terms of what we want to choose as a u. Now, I'd probably encourage you before you maybe even keep on with this video is to kind of ask yourselves what might be a good choice for u. Now, we notice that if we're thinking about the fact that when we choose a u, we are also going to need to get a du that represents some of the material in our integrin that's going to be subbed out. The fact that we've got sines and cosines here is a good indicator that one of those will be our u and one of those will be our du. I'm going to go ahead and I'm going to choose a u of 2 sine of x. So I'm going to let it be the exponent of that natural exponential there. So let's see how that plays out in terms of our du. So if we take the derivative of 2 sine of x, we're going to get 2 times the cosine of x dx. And this is looking pretty promising right now. So we know that this is going to end up, we've chosen this to be our u, and then our du is pretty close. We just have that extra 2 out in front. So kind of like last time, what we're going to do is we're just going to divide both sides by 2. And that's going to give us 1/2 du is equal to the cosine of x dx. And now this part right here, we know is just going to be 1/2 du. And now hopefully what results is something that we can actually integrate. So let's see if that turns out to be the case. So if we do all of our substitutions, we've now got the integral of 7 times e to the power of u times 1/2 du. And I'm going to go ahead and I'm going to, as I did in the last one, I'm going to pull the constant multiples out front. So I'm going to pull out the 7 and the 1/2. So we'll have 7 times 1/2 times the integral of just e to the u du. And now we should all kind of breathe a collective sigh of relief because this is definitely something that we know how to integrate. So the integral of e to the u is just going to be e to the u. So as we integrate, we're going to have 7/2 times e to the u plus c. And then we just go ahead and do our back substitution. And we've got 7/2 times e to the power of 2 sine of x, and then we've got our plus c. Now, one thing that I will mention about this is maybe it was tempting to choose cosine as our u. Notice that if we had let cosine be the u, then yes, we would have had a sine of x dx, but our sine of x is not connected with that differential dx right there. So that would have been a problem. We would want those two pieces to be connected like cosine of x and dx were. So again, this is just one of these examples where, maybe at first it wasn't clear what would be the u, but as you do a few of these, you start to say, okay, well maybe choosing that exponent of an exponential function would be a good choice for a u as well. Okay, so we'll keep, we're going to be doing a lot of examples here to continue to build that intuition as we go through this.